congruence that we've done. So side, side, side is just all three sides. Side, angle, side, the angle will be between two sides. Angle, side, angle, the side will be between two angles. And then angle, angle, side, the side will follow two angles. So as you go around the triangle, you just follow the leader kind of thing, and it goes angle, and then side. I'm not. I'm just... And we have the properties of isosceles triangles. As you know, isosceles triangle has two sides that are the same. Okay, the legs are the sides that are the same length. It shouldn't be a vertex angles, it should just be vertex angle. There's only one. The vertex angle is the angle between the two legs. Okay, and then the base angles are the other two angles. Okay, so if this is an isosceles triangle, so this leg is the same as this leg. These will be my legs. This angle will be my vertex angle. And these angles will be my base angles. One thing to keep in mind, I drew this upright to where the two legs or the two sides going up, but this can be rotated any direction. So if this triangle was turned sideways, the base angles would be at the top and like on the bottom, and then the vertex would be over on the side. So just because they're called base angles doesn't mean they're always going to be at the bottom of the triangle. Does that make sense? Right. So just, you always look at what two legs are the same. The one between those is the vertex, and then the other two are the base, wherever they're located. They could be upside down, it could be sideways, it could be rotated all over the place. So just, you know, I know that we get into, when you were finding areas of triangle, it was half the height times the base, and the base was always the bottom. But that's not the case with the base angles. They're not always on the bottom.
When did you do that?
7th grade. Okay, so the isosceles triangle theorem tells us that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So basically, we start here with those two sides being congruent, and that gives us that these angles are congruent. Okay, we start with the sides and we get the angles. A terrible drawing.
Opposite of those sides.
Yeah, so opposite. So the opposite comes over here and this opposite comes over here. So the two legs give us that the base angles are congruent. So okay. Yeah, so if you have your two legs, two sides that are congruent, that makes these two angles congruent. So the legs being the same size makes these angles the same size.
That's what makes it an isosceles.
The legs make it the isosceles. The fact that the two sides are the same. All right, so the original theorem tells us the legs are the same size. That makes the angles the same size. The converse goes the other direction. We have the angles are the same size. So we start here with the angles, and that gives us the legs. So in the first one, we start with the legs, we get the angles. In the second one, we get the angles, or we start with the angles, so we get the legs.
Two angles what? And a triangle?
In a triangle. If two angles in a triangle are congruent, then the sides opposite those angles are congruent. So here, basically what we're getting is that the congruent angles gives us congruent sides, which gives us an isosceles triangle. Okay, so they're the same idea. Both of them are saying that the sides are congruent and the angles are congruent. It's just with the first one, you start with the sides to get the angles, and then the second one, you start with the angles to get the sides. But they both tell you the same thing, that those sides and those angles are both going to be congruent. Does that make sense? It's just moving in two different directions. So essentially what you have is an isosceles triangle has two congruent legs and two congruent base angles. Okay, so what we have, if AC is congruent to AD, so we're looking at AC and AD to be congruent. Those are the two sides. We want to know which angles are congruent. So we're going to go opposite. So that gives me this corner angle here and this corner angle here. So that's going to be angle ACD is going to be congruent, to angle D. And I said ACD so that we know we're talking about the whole thing and not just that little, like a little piece of it, because it's cut in half here.
How is C and D congruent?
Because if these two sides, so if I were to draw this triangle, say like that, I'd have these two sides congruent, which gives us the angles. Do you see what I mean? Okay. Let's go to a different color. If BE is congruent to BC, so BE and BC, we want to know which angles are congruent. Well, this angle is opposite BC, so that's angle E. If it's confusing, break it out and redraw it. Does that help? So take that little triangle out of the picture and draw it off to the side.
Okay.
And then it might be less confusing.
Okay.
Is that helpful? Okay. So once we have that, I know that these two angles are congruent. So angle E, not E, BEC, I'm going to call it BEC, is congruent to BCE. Is that better? Questions on those two at all?
So can you explain number one again?
Yeah, we had the big triangle. We're looking at the big one, right? So I drew it here. AC, that's this line, is congruent to AD, that's this side. So we go across, and we get that these two angles are congruent. Because it's always going to be the two base angles. So basically not the angles between the two congruent sides, but the other two. So once I look at, here, let me redraw this. Draw them a little better. Get the orange back. Okay, I have that triangle, right? ACD. And these two are the same. This angle here, angle A, is the vertex angle. That's not going to be congruent to anything. So that leaves me these two angles.
Okay, can I make B the vertex?
No.
And then the A and the C?
No, because these two lines are the same, and the vertex is going to come between them.
You're right.
Does that make sense? Okay. And then if we do the same thing with BCE, the little triangle, if I pull that one out, I've got these two sides are congruent.
The B is the vertex?
The B is the vertex, so that leaves me angles C and E. Okay, now I said BCE because I'm talking about just this little piece right here, and BEC because I was talking about just this little piece right here. But if you took it out and redrew it, you could just say angle E and angle C from this picture. But if you're using it from the big picture, we can't just say angle E because what angle am I talking about?
So is it okay if we do it like that and take it out?
Yeah, if you take it out and draw it, that's fine. Okay, if I have angle EBA is congruent to angle EAB, well, EBA is this angle, and EAB is this angle, so I'm talking about this triangle right here. This one.
And EB would have to be, line EB would have to be congruent with line EA?
Yeah.
B is congruent to A.
Wait, how?
Because EBA, that's this angle, EBA, is congruent to EAB.
So because E
EAB.
started first, then it's gonna be our vertex?
Yeah.
Okay.
So that gives me that AE. Whoa, what happened there? AE, that's this side, has to be congruent to BE. And then my last one, I have C, E, D, and C, D, E. So I'm talking about this triangle over here on the end. Let me get a different color, purple. And I have CED, that's this angle. CDE is this angle. So that means these sides. So CE congruent to CD. Okay, and triangle is equilateral if and only if it is equiangular. And we talked about this a little bit already. I said that those two things were really the same. If you were equilateral, you were equiangular, and if you were equiangular, you were equilateral. You had to be both. You couldn't be equiangular and scaling. It doesn't work. So basically, A, B, and C are all going to be congruent. And then the sides, AB, AC, and BA will all be congruent. Okay, and they make each other happen. If you have all the same angles, that makes all the same sides. If you have all the same sides, that makes all the same angles. You're both. And then the final little corollary here is that each angle so if this is equilateral, angle D is equal to angle F is equal to angle E, and they all equal 60 degrees. Okay, because these two are the same, that tells me that these angles are the same. And since this one is 60, that means that this one is 60. These two sides being the same tells me that these two angles will be the same. And that one's 40. So I can subtract that from 180. And I have 140 left to take up these two angles. But since those two angles are the same, so I'm going to divide by 2, and they're both going to be 70.
Wait, what?
Well, because I have this angle, right? And the whole triangle is 180. So I take the 40 out, and that leaves me 140 between the two angles.
Oh, okay, so you divide it by
And divide it by 2. Use the same idea to find missing using algebra. These angles are the same, which makes these sides the same. So these are going to be equal. So 3x minus 10 is equal to 2x plus 4. And then I can solve for x, so I subtract 2x from both sides. And I get x minus 10 is equal to 4. And add 10 to both sides. So x would be 14. And on this one, it just said find the value of the variable. We didn't actually have to find the length of the side. But if we wanted to find the length of the side, we just plug x back in. And so we'd have 28 plus 4. So it'd be 32. And then this one would be the same. So if you needed to find the sides, you could.
So how did you get the 32?
2 times 14
Oh, okay,
plus 4.
okay.
Now on this one's a little bit more complicated. We have a 90-degree angle.
You plug that in with it?
Well, what I'm going to do is, because these two sides are the same length, that makes the angles the same, right? So this one is 2x plus 3, and this one will also be 2x plus 3.
You would take 90?
Yeah.
Can you just take 90 out of 180 and
Yeah.
divide that by 2?
Yeah, that's what I was going to say. So I've got 2 of those, right? So actually there's a couple different, we could do this a couple different ways. We could do 2 times 2x plus 3 would be 90. Or you could take 90 and divide it by 2 to get 45 and say 2x plus 3 equals 45. Or you could do 2x plus 3 plus 2x plus 3 plus 90 equals 180.
Yeah, but
If
we're
you wanted to
solving
go
for the variable.
We're solving for the variable, but we could still do that. Like there's more than one way to get to this problem, so you could use the way that you saw. In any case, if I do it this way, I get 4x plus 3 equals 90, and I subtract 3 from
I think you're supposed to.
both sides. That's 90, not 9.
I think you're supposed to distribute it too.
Plus 6. Yes, you are. Thank you. That's what I meant. I was just checking to see if you guys are paying attention.
So it's 84.
So 21, and if I did this way, I'm going to subtract 3. And I get 2x
How
is
were you
equal
gonna
to
do
42.
it in the beginning?
I was going to show you all 3. But I was going to do this one first, and then show you this one, and then show you add them all up to 180.
Oh, so those are, okay.
Yeah, this is, you see, if you look, we get the same answer. So we have more than one approach to this kind of a problem, and you can use the approach that you see. And as long as you do the steps right, you can see we get the same answer.
Mm-hmm.
So whatever approach made the most sense to you. So if you saw the divide it by 2, 90 divided by 2 equals to 2x plus 3, that works. If you saw that you had 2 2x plus 3s and you add those together to equal 90, that works. And if you saw I have two 2x plus 3s and a 90, and you add all of it together to equal 180, that would also work. So whatever you see in the picture, you can get there.
What's the homework?
The homework is